Okay, so for polynomials, what we're paying attention to, if it is a polynomial or not, you're looking at the exponents and they must be non-negative integers. To put it in standard form, it's the highest exponent down to the lowest exponent. And then to find the degree of the polynomial, you're looking at the highest exponent. Okay, so we're telling whether these are polynomials or not. And if they are, what is the highest exponent? What is the degree? This is 3 minus 2x to the fifth. So this is a polynomial, and the degree is 5. If it was written in standard form, you would put the negative 2x to the fifth first, then plus 3. The next one, the square root of x plus 1. This one is not a polynomial because the square root of x is equal to x raised to the 1/2. The exponent is not an integer, so that means it's not a polynomial. For number 3, this one is a polynomial. It's degree 2. The highest degree is 2. Number 4, because of this exponent of negative 2, it's not a polynomial. And I have one more. Four x to the fifth times 2x plus 3. And this is a polynomial. It's not degree 5 though, it's actually going to be a degree of 6 because this is a 1 here, so that's a linear. When it's multiplied with this x to the fifth, you're going to get an x to the sixth, so that means the highest degree would be a 6, so it's a 6th degree polynomial. Okay, so if I have f of x as a polynomial, and I know that x equals a is a solution to fx equals 0, when a is a real number, then I have 4 relationships that occur. The first relationship is that x equals a is also going to be a root of f of x equals 0. X equals a is a 0 of the function f of x. It would also mean that the coordinate a0 is an x-intercept of the graph of f of x. And I would be able to know the factor of one of the factors of f of x is x minus a. So x minus a is a factor. So if I'm trying to find the zeros of this function, what I'm going to have to do is I'm going to factor it, and then once it's in factored form I can find the zeros from there. So I first can factor out an x squared plus x minus 2, and then that can factor into x plus 2 x minus 1, and I still have that x out in front. So to find my zeros, I'm going to set each of them equal to 0 and solve. So that means I have x is equal to 0, negative 2, and positive 1. So now we're going to talk about the multiplicities of a 0. And the statement that this is going to come from is if I have x minus a raised to the n as a factor of f of x, then what that's going to mean is that a is a 0 of f of x, but it's going to be with a multiplicity of n. The n is the exponent. So to tell what the zeros are, we're going to do the same thing that we did before, except we're going to state the multiplicities. So this is already in factored form. Okay, I have x minus 1 squared times x plus 3 over 5 raised to the 7th times 2x minus 3 raised to the 4th. And what I'm going to do is I have x is going to equal 1. That comes from this one, but that's going to be with a multiplicity of 2. I'm also going to have negative 3 over 5 as a 0, and that's with a multiplicity of 7. And then this one is going to be 3 over 2 with a multiplicity of 4. The way I got 3 over 2 was you're setting each of them equal to 0, so I add the 3, divide by 2, so it's going to be a positive 3 over 2. That's all I'm going to put on this one. I'm going to add the in behavior chart onto the part 2 for polynomials.